Okay, so let's do another problem. And again, these are word problems, so I'm going to read them to you. So again, take notes as I'm reading. So there's two parts, part A and B. So part A says a population P of T of a culture of bacteria is given by this function. So this function is P of T is equal to 5,000 times 2 raised to the T divided by 4. Okay, now where T is the time in hours after the culture started, it says write the rule of this function using base E. So what we want to do is rewrite this rule, right? But instead of having a base of 2, we want to have this written as a base of E. So how would we do that? Well, let's start by seeing how we could do that. Okay. Well, if we want to get a base of E in there, then what we're going to need to do is, again, we'll use that rule that we're talking about. And so let's use the fact that we can raise both of these. Before we do that, let's simplify this. Okay, so we're going to use this as P of T over 5,000. We're going to have that equal to 2 to the T to the 4th. And so now what we're going to do is we're going to raise both of these. We're going to use that property. So I'm going to say, okay, let's raise this to e to the natural log of P of T divided by 5,000, right? So I didn't change anything. I just rewrote this as an equivalent expression, okay? And now I'm going to do the same thing over here. I'm going to write this as e to the natural log of 2 to the T over 4 power. Okay, so far so good. And now what I'm going to do is I'm going to simplify this side for a moment. So just disregard this, but I'm going to rewrite this. So this is going to be e, and this is going to be what? I'm going to pull the exponent out, and I'm going to write this as e to the what? T times the natural log of 2 all divided by 4. Right? Now, looking at this, I really didn't have to exponentiate both sides because all I did was rewrite this as an equivalent expression, right? So this is the same as this. So I didn't have to do anything on this side. Okay? So now look what happened here. So now what happens? This is just what? E raised to what? T times the natural log of 2 divided by 4. So this is now our K value, our constant, right? So now the equivalent expression, now I can multiply back 5,000 on both sides, and so our new expression becomes P of T is equal to 5,000 e to the what? Natural log of 2 over 4 times t. And there's our equivalent expression, but with a base of e instead of a base of 2. Now it says, find the population after 12 hours using both forms. All right, so let's do, that's part B, right? So now we've got 2 models, right? Let's use them both, see what we get. So P of, this says what? 12 hours. So P of 12 equals 5,000 times 2 raised to the 12 divided by 4, which equals 5,000. So that's going to be times 2 raised to the 3rd power, which equals 5,000 times 8, which gives us 40,000 bacteria. Okay? Now, let's do the same thing using this one. So we've got P of 12 equals 5,000 times e to the natural log of 2 divided by 4 times 12. Okay? Now, this is going to equal 5,000. And this is going to be what? Now, again, you could stick this in your calculator or just use the property of exponents here. So this is going to be, I can rewrite this as e, and this is going to be the natural log of 2 times 12 divided by 4, right? And this is going to equal, here's the thing, we end up basically converting this back to this. So you see that they're equivalent. I'm just going backwards from the proof that we did before. So instead of doing that, we can just go ahead and plug it into your calculator. I mean, we can see that these are going to be equivalent. Well, let's just go ahead and plug it into your calculator. Just take e to the power of natural log of 2 divided by 4 times 12. So we'll just do 3. So we'll just do 3. So if you do that, you're going to get the same answer. But do it. Prove it to yourself. Don't just take my word for it. Have a great day.